I'm Cassie, and I'm going to walk you through question 9, which is related to passage 2 of the AAMC official physics question pack. So in this question, they give you the frequency of the first harmonic. It's 100 hertz. Now, remember in the explanation to question 7, we've talked about the fact that for each harmonic after the first harmonic, remember the first harmonic is also known as the fundamental frequency, the frequency of those subsequent harmonics is just a multiple of the fundamental frequency. So if we're told that our first harmonic has a frequency of 100 hertz, we're going to just call this F is 100 hertz, then our second harmonic is just going to be 2 times F, or 200 hertz. And what would our third harmonic be? It would be 3 times F. It'd be 300 hertz, etc., so on and so forth. So this is a classic MCAT question in the sense that they give you the frequency of something and they ask you about the period of something else. So a lot of students are tempted to stop here and be like, oh, the answer is 200 hertz, right? But they're not asking for frequency, they're asking for period. Remember, we also talked about in question 7, the relationship between frequency and period. Whereas frequency is the number of cycles per second of a waveform, period is how long a single cycle takes in seconds. So those two things are inverses. If you have more cycles per second, a higher frequency, you're going to have a lower period. It's going to take less time for a single cycle to be complete. So we use the equation T for period, always a capital T, equals 1 over frequency. So if we know that our frequency is 200 hertz for our second harmonic, we can go ahead and plug that in here. What's 1 divided by 2? We know that's 1/2. But I don't have 1 divided by 2. I have 1 divided by a number that's a lot bigger than 2. We know that our resulting quantity is going to be much smaller than 1/2. How much smaller? It's going to be smaller by the amount of zeros you have in the 200, right? So we have 2 extra zeros in 200. And so we're going to move our decimal point 2 places to the left. And we're going to end up with 0.005 seconds. Now, just to review that unit conversion really quick, we had 1 divided by 200 hertz. Remember, hertz are the same thing as cycles per second. So we had 1 divided by cycles per second. So of course, anything where we're inversing it, we're just going to get the result is going to be seconds per cycle. And then we leave off the cycle because we're assuming it's 1 cycle. And that's how we end up with our units being seconds. So takeaways, each subsequent harmonic is just a multiple of the frequency of the first harmonic. So if the first harmonic is F, the second harmonic is 2F, and so on and so forth. So frequency increases as you increase harmonics, which since period is inversely related to frequency, period decreases as you go up harmonics. That's why we have such a small number here. That's why we have such a small portion of a second here for our answer. I hope this helped. If you have any questions, drop a comment and please subscribe for more content like this.